Hello to anyone who might be watching this. I don't know if anyone will be watching this, but hopefully, I don't know. My name is Kason Allen. This is my YouTube channel. Right now I'm calling it Irresponsible Science. But, yeah, I guess it's just a preview of what I have to come. Actually, why even bother editing it? Yeah, it's supposed to sound genuine. Oh, in this channel, I'll pretty much be doing different experiments because I myself is learning different things. I want to become a mechanical engineer in the future, and this is really just gonna be a journey of me learning stuff and showing whoever wants to watch what it is. But yeah, this video I'm gonna play next is pretty much just a preview what's to come, what I'm gonna be posting and stuff. Don't mind me in this. I'm a little dead because it was for a STEM-based competition, and I learned how to make the video a night before it was due. I wasn't even given like 20 hours, so along with other stuff. But yeah, hello, my name is Kason Allen. My project title is the Arduino controlled robotic arm utilizing flux pinning. So this entire project is pretty much the possible progression of how superconductors can be integrated into robotic arms to have them be more free moving, have them be frictionless, and practically change the way we look at robotic arms or even prosthetics. The idea started with mainly just a joke and me saying to myself, what if I just saw a prosthetic arm that was like floating in different pieces? So, this piece would be isolated from this piece, isolated from this piece. After watching a video on how flux pinning or quantum levitation works. And after that, I started thinking maybe this could be the idea for my next science fair project. This was around the time that the Georgia Science and Engineering Fair ended, so I started working on just quick sketches of that, seeing how it could possibly look, and doing more research on the science of flux pinning. Come the summer of 2021, I started doing much more research on flux pinning, on programming with Arduino, because I knew I'd have to understand a bit of how robotics work, understanding electronics, and a little more design principles when it came to robotic arms. Going into the project, I knew that I wouldn't be able to follow the exact principles that go with robotic arms because they're not exactly going to be constructed the exact same. But I did know I'd have to still use some certain rules, like how weight distribution could be spread out in the second axis. After much of that research was done, I was able to make a full-fledged illustration of how I wanted the project to look, which was pretty much separating each part of the robotic arm based off of where its joints were, and replacing those joints with a magnet and a superconductor. The superconductor would be white BCO, yttrium, barium, copper oxide, that has a critical temperature of 92 Kelvin, which would be easily achievable with liquid nitrogen. The next step after this was being able to obtain every material I needed: liquid nitrogen, superconductors, more 3D printer filament, a way to hold the liquid nitrogen, all this stuff. And at the time, like in the middle of July, I did not think that was realistic until school came. A lot of it was quite hard to obtain, very costly, but I ended up getting a 6-liter dewar for liquid nitrogen, superconductors that originally weren't as useful as I hoped, and all the other materials, all the electronic components that I had learned how to use over the summer. The initial design process using a web-based platform named Tinkercad probably took in all, the initial design process probably took in all, I want to say 2.5 weeks to get everything working. I started 3D printing it with Ender 3 V2 that I started using last year for my science fair project, and many of the pieces did have problems coming out, but I was able to print them all, integrate them into with the electronic parts, and it worked pretty well. I was able to safely use the liquid nitrogen in order to activate flux pinning for the superconductor. And originally the procedure was to have the superconductor in a bowl and pour liquid nitrogen all over it. Then I would place it into superconductor casing that was placed in this tilt mechanism at the top of the first section of the arm, and I could orient the magnet above that. So originally the orientation was the superconductor would be here and the magnet would be here. This was only because the superconductor wasn't as efficient in flux pinning as I would have liked it to be, so it could only hold very little weight, the magnet not being much weight at all. And this procedure took quite a bit of time to achieve, so by the end of it, like, the superconductor would have already heated up, so I would have only had a few seconds to test it each time. After winter break, I purchased another superconductor from quantumlevitation.com that was more capable of flux pinning. This was able to flux pin with much larger magnets, support its own weight, and a little more weight on top of that. With this, the procedure changed. It was much more simple to execute certain functions when controlling the robot. Originally, you had to plug in numbers to tilt the mechanism this way or that way through the computer, and this would obviously take a lot of time because serial commands take a few seconds to register from the computer to the Arduino. But now, because I had modified many things, I have a control system that's more user-friendly, more like practically a video game. I'm able to orient the magnet and superconductor much more easily with the use of a joystick and a touch sensor. This superconductor is able to flux pin quite a bit longer than the old one. It's also, the actual superconductor inside is only 3 microns thick, allowing it to be more crystalline and flux pin more efficiently than before, allowing me to demonstrate what the intended goal is much better than before. I think many of the issues I ran into were solved during this entire period between the school science fair and the regional science fair, but I think there are also many that I also haven't solved, but also many that have risen from certain successes that I've had. One being that certain electrical components wouldn't work, which caused me to have to switch to a less user-friendly way of controlling the entire device the first time around during the school science fair. But since I was able to solve that this time over, I was able to control it with the joystick, so now if another person were to use it, they'd be able to understand almost immediately how all the functions work. Overall, with this project, I have come a long way since the beginning. There is much to be worked on, much more progress to be made, and hopefully soon I can have a full version of what the intent was in the beginning, having a full robotic arm with each of its joints isolated with the use of superconductors flux pinning with each other. Many issues I ran into, such as programming, electric component problems, were anticipated, but not to the degree that that halted me the first time. This time I was able to solve many of the issues, but there's still been some issues here and there, like such as my code getting deleted actually last night, so that was a bit of an obstacle. But moving forward, I know what design changes need to be made, what things to look out for, and how to improve upon my project so that I can hopefully have a full prototype of what could be the future of robotic arms. So hopefully you like that video. I don't. But yeah, hopefully I post more in videos to come. That experiment I plan to take a lot further. Like, I have different designs for it. Like right here, I have a whole different design that I plan to use by taking apart a fan, using the solenoids and that. as an electromagnetic track. But hopefully you enjoyed the video. Goodbye.